Welcome to section 9.8, solving quadratic equations by completing the square, and this is our second video, so that's kind of exciting, and these are just practice problems. I'm going to add a little bit more to our last two problems so we can play around with that, but we're essentially doing the exact same thing as the section 9.8 video number 1, but we're just doing it over and over again so you can solidify some of your knowledge. So to start out with, let's review our steps that we need to take. Step 1, to complete the square, we need to write the expression in the form x squared plus bx equals c. Our step number 2, we need to find what b divided by 2 squared is. So there's our b term. We're going to divide it by 2 and square it. And then we're going to add that quantity to both sides of the equation. So if we're looking at this equation down here, we're going to add that b divided by 2 squared to this side, and we're going to add it to this side. So we're going to add it both to the left and the right. Step number 4, we're going to factor that perfect square trinomial, and that perfect square trinomial will be on this left-hand side. And then we're going to take the square root of both sides. Last but not least, we're going to create two equations using the positive and negative square roots, and we're going to solve that equation. So let's actually go through these steps with this equation here. We have x squared plus 10x is equal to 9. So if we look at this, step 1 is done. Number 1 is done. Check that off the list. It is in that x squared plus bx equals c format. There is the x squared, here's our bx, and here is our c. So if we're looking at that, we now need to do our step number 2. Our step number 2 tells us that we need to take that b divided by 2 and we need to square it. So our b term is equal to 10. And so we're going to take 10, we're going to divide it by 2, and then we're going to square that baby. So 10 divided by 2, if we did that math, 10 divided by 2 is 5. And if we were to square it, we end up getting 25. So that is our information that we're eventually going to add to both sides of our equation. So let's rewrite our equation. We're going to rewrite it as x squared plus 10x plus, and I'm going to leave a big space here because we're going to add something there, and we're going to add a negative 9. And once again, I'm going to add a big space at the end, so plus something. So let's give us a little bit more space. We have x squared plus 10x plus 25. We're going to put that in there, and we're going to say 9, or negative 9 plus 25. After that, so we've now done step number 3. Number 3, awesome. Step number 4 tells us we need to actually do create a perfect square trinomial out of this. So we need to say x plus something is equal to everything on the other side and everything on the other side. Negative 9 plus 25, that gets us 16. All right, so after we do that, let's actually find our perfect square trinomial. We have x and x. And if we think about it, this 5 is going to go on each side because this term is our b divided by 2 squared, and that b divided by 2 info is what goes into our perfect square trinomial. And we're going to just add a couple of pluses because this is a plus right here. So x plus 5 squared is equal to 16. Awesome. From here, we need to take our square root, so that is our step number 5. We need to take the square root of both sides, square root of both sides. That square root takes care of our squared, so we have just simply x plus 5 is equal to the square root of 16. The square root of 16 is plus or minus 4. After that, our step number 6 tells us that we need to create two different equations. We have x plus 5 is equal to a positive 4, and x plus 5 is equal to a negative 4. Last but not least, we need to solve those two equations so we can get a couple of x values. So we are just going to subtract 5 from both sides. We might as well do it on all of them. So we'll get x is equal to 4 minus 5 is a negative 1. And x is also equal to negative 4 minus a negative 5, or a negative 4 plus a negative 5 is negative 9. So those are the roots of our equation, negative 1 and negative 9. That is where that parabola will cross the x-axis. Let's try another problem. We have t squared minus 8t plus 5, or minus 5 is equal to 0. Our first step, we need to add 5 to both sides. So we can get it in that form. T squared minus 8t is equal to 5. They're trying to throw us off with that whole t thing, but I think we can handle it. It's essentially just an x. I'm now going to find that b over 2 squared information. So we have b, which is negative 8. We're going to divide it by 2. We're going to square it. So b divided by 2 is negative 4 squared, which equals 16. So that is what we're going to add to both sides of our equation. So let's add that in. We're going to add 16 in there. So t minus 8t plus, or t squared minus 8t plus 16. If we were to write that in factored form, we can say it's t minus 4 squared is equal to 5 plus 16, which is equal to 21. All right. Next step, let's make some more room for ourselves. We have t minus 4 squared. We need to now take the square root of both sides. Square root of t minus 4 squared is just t minus 4. And square root of negative 21 is just plus or minus the square root of 21. There is no perfect square for 21, so that is what we've got. Last step, we need to create two equations. So we have t minus 4 is equal to positive square root of 21. And we have t minus 4 is equal to the negative square root of 21. Our last step is we need to actually add 4 to both sides of our equation, and we're going to do that all the way across and get both of those equations taken care of in one fell swoop. So we have t is equal to 4 plus the square root of 21, and we have t is equal to 4, oops, wrong color, 4 minus the square root of 21. So those are our two answers. We're getting kind of fast here. We've now done 2 problems in 8 minutes, and I can't find my other problem. All right, there it is. So the next question is, what if your equation looks like this? So if you notice, I actually already highlighted it for us. What if we have a negative 2x squared plus 12x minus 20 is equal to 0? So in other words, what if your a term is not 0? So if a doesn't equal, or is not 1, sorry, not 0, 1. If your a term isn't 1, what you need to do is you actually need to divide by that a term. We have a negative 2 in this case, so we're going to divide every single term by a negative 2, including that 0 on the end. So we'd end up getting x squared minus 6x plus 10 is equal to 0. 0 divided by 2, negative 2 is 0, so not negative 2 divided by 0, that would be undefined. So looking at this, we can now go through our problem. So we're going to say b divided by 2 squared. Oops, wait, I'm jumping the gun. I first need to get it into that x squared plus bx is equal to c formation. So we're going to subtract 10 from both sides. So then we'd end up with x squared minus 6x is equal to a negative 10. Now we can identify our b term, negative 6, and we can say negative 6 divided by 2 squared. So negative 6 divided by 2 is negative 3, and we're going to square it, so we're going to get 9. So we then have x squared minus 6x, plus 9 is equal to negative 10 plus 9. We've added it to both sides of the equation, keeping everything balanced. X squared minus 6x plus 9, we can factor that. We can factor it into x minus 3 squared. And that is equal to negative 10 plus 9 is a negative 1. We can do that math. And then we need to take the square root. I already see a problem. I hope you guys see a problem. I'm going to make it really obvious. That's a problem. So we have the squared and the square root cancel each other out. So we have x minus 3, and that is equal to the square root, positive or negative, square root of negative 1. And looking at that right there, the square root of negative 1, with our current algebra knowledge, we can say that there is no real solutions. Now, there are imaginary solutions, but there's no real solutions to this particular problem. Because of the square root of a negative 1, we cannot take the square root of a negative number at all. It's not going to work out for us. So no real solutions is the answer to this problem. So understand, that can be a situation. Let's see if we can find our last problem. Here we go. Last problem. 3x squared minus 10x is equal to negative 3. Our step 1 is already taken care of. It's in that x squared minus bx equals c format. The only bad part is we need to divide by 3 on all of our terms. We need to get that a to turn into a 1. If we do that, we have x squared minus 10 divided by 3x is equal to negative 1. Okay, so here comes the tricky part. We need to actually do that b divided by 2 quantity squared situation, but if we look, our b term is a tricky number. It's a fraction. Oh my gosh, let's freak out. Actually, let's not. All right, so our b term is that negative 10 thirds. So we have negative 10 divided by 3, and that is over 2. And we're going to then square it. 10 divided by 3 divided by 2, technically we are dividing by a fraction. If we look at the number 2, we can say it's 2 over 1. So we can rewrite this division of a fraction as multiplication of its reciprocal. So we can say negative 10 divided by 3 times 1 over 2 squared. That is the same exact thing as dividing by 2, and we figured this out way long ago at the beginning of the year, and hopefully you also did it in like 6th and 7th grade. So let's do some cross simplification. We can simplify the 10 and the 2, and we can say 5 over 1 instead. So let's now multiply straight across, and we get negative 5 over 3 squared. That ends up being 25 over 9, and it's positive because a negative times itself, negative times a negative, is going to get us a positive. So that's what we're going to be adding to both sides of our equation. So let's make ourselves a little bit more room. So we have now x squared minus 10 divided by 3x plus a quantity is equal to negative 1 plus that same quantity. And we just figured out what that is. It's 25 over 9. 25 over 9. Let's do a little bit of this math. Let's get this taken care of. We need to now factor this into its perfect square trinomial form, and I'm actually going to bring this up so we can see it again. And if we're going to factor it into its factor form, we're going to say x minus 5 over 3 squared is equal to negative 1 plus 25 over 9. Negative 1 plus 25 over 9, we need to deal with that. So let's think about that information. Let's do a little sidebar. Negative 1, we can rewrite that as negative 9 over 9. Know that you can always rewrite a number as a fraction, and you can rewrite it in any form as long as you keep everything equivalent, keep everything proportional. So we have negative 9 divided by 9 plus 25 over 9. So Negative 9 plus 25. We're doing this math across the top. That's how we add fractions. Negative 9 plus 25, we end up getting 16. Ooh, I like that number. It's a squared number divided by 9 over another squared number. So that's really cool that we have squared numbers happening. That's super duper helpful. It doesn't always happen in real life, but thank goodness it happens in our algebra book. So we have x minus 5 divided by 3 squared is equal to 16 over 9. Our last couple of steps, we need to take the square root of both sides. Take the square root of both sides. That squared root symbol gets rid of our squared. So we end up with x minus 5 thirds is equal to the square root of 16 over 9, which is square root of 16 is a 4. And the square root of 9 is a 3, and we're not going to forget that whenever we take the square root of a number, it's also plus or minus. It's positive or negative 4 over 3. Last step of this, we need to actually create two equations, and we see that there's two equations because we have two answers. So x minus 5 thirds could equal a positive 4 over 3, and x minus 5 thirds could equal also a negative 4 over 3. After that, we need to add 5 thirds to both sides, and we're going to do it all the way across on all of our equations so we can get it all taken care of at one time. So we have x is equal to 4 thirds plus 5 thirds, which is 9 thirds, or 3. Whoa, a whole number. That's kind of cool. Even after all this fraction work, things are kind of all shaking out. And then we also have x is equal to negative 4 plus 5, which is 1 over 3. So we have one fraction answer and one whole number answer. And that is how we do completion of squares. We're completing the square. Let's see if I can find our way all the way up to the top. We've done a lot of work. So play around with the homework. If you have any questions, be sure to ask them. I will be happy to answer them, and I hope this helps. Thank you so much. Bye.